Section 1.4, Relationships and Patterns. If we look at the terms, we've got 1, 2, 3, and 4, the term number. And if we look at the term, it's going 3, 6, 9, and 12. So the term number goes up by ones. And if you look at this one, it's going 3, 6, 9, 12. It is going up by 3 every time. So there to there goes up by 3s. From there to there, it goes up by 3s. So the question is, how's the term related to the term number? Well, the easiest way to do this, you notice that this one is 2 more than the term number. This one is 4 more than the term number. This one is 6 more than the term number. This one is 8 more than the term number. If we go by the pattern, okay, so when you go from there to there, it is 2 more. When you go from there to there, it is 4 more. There to there, it's 6 more. There to there, it is 8 more. The next one is going to be 10 more. So if I wrote 5 and 15 would be my term. Now we're trying to see if we can write a relation for the term. In other words, can we write some sort of a relation that we could just plug in the term and it would give us the term number every time? Well, let's give it a shot. So we'll say let n represent any number. So n would be the term number. Now the easiest way to figure out exactly which one it is to do this. I'll start off by getting rid of a few of these that I don't need here. Okay, and we're going to look at how much is the term going up every time. And as we said down here, the term is going up plus 3. So in front of the n, we should put down 3. So that's how we get the number that goes in front of n, or whatever letter you choose to use. Now, let's plug in one of the term numbers. Excuse me. Let's plug in one of the term numbers. If we count this one up, this one put in 2, we're going to get 6. If we plug in 3, we're going to get 9. So there's nothing else that we need to do to this to make that equal the term. Okay? So when we go 3 times 1, it's going to give us 3, so we need to go 0 more, so we don't even need to put that in. Okay? So the relation for this one is going to be 3n, or is 3 times the term number. In this one, it's a little bit different. So let's try it again. We're going up by 1, 2, 3, 4. We're going up by 1s again. Now let's go from this one to this one. We're going up plus 1, plus 1, plus 1. So we're going up 1 every time. So we're going to go and say that n is the number again. And we're going to say how much is it going up? It's going up 1. So we'll put 1 in front of the n, which really doesn't do anything to this n. Now, let's plug in one of the numbers. Let's plug in the first one. It's always easiest to plug in the first. Let's put 1 in for n. So 1 times 1 is 1. So how many more do we need to get to 6? So we'll need 5 more. And we don't even really need to put this 1 in front of the n. Let's test it for the second one. Let's put 2 in for n. So 2 is in there, plus 5 more is 7. So it seems to be working. Let's put 3 in for n. 3 plus 5 is 8. So it seems to be working. There's our relation for this one. So the trick to writing a relation is see how much the term is going up, and that will be your number in front of n. Then you plug in one of the numbers, and then you see what you get and what you need to add to it to make it equal the term. So I could have plugged in 3 and said 3. Now how much more do I have to add to 3 to get to 8? And the answer is still 5. So here's another one. We have the term going up by 1, the term numbers, and we have the term going up by 4. By 4 again. So it's going up by 4, so we will do 4n. Now let's take this first one here and plug it in. So let's take him and put him in for 1. or for n. So we've got 4 times 1 is 4, but we need to get to 6. So we're going to have to add 2 more to get to 6. Let's test it by taking another one of our terms and seeing if it works. Let's put 2 in for n. So 4 times 2 is 8, plus 2 more is going to give you 10. So it works out nicely. So that's how you decide or write an equation, or sorry, not an equation, a relation for every bit of data you have up there in your box. All right, now we're going to take an input and output table. This is section 1.5. So here's your input is x. Your output will be 3x, or 3 times that number. So when we put 1 into here, 3 times 1 is 3. When we put 2 in for x, so put 2 over there, and it's 3 times 2 is 6. Put 3 in for x, and it's 3 times 3 is 9. And if you put 4 in for x, 4 times 3 is 12. And again, you can see the pattern. It's going up by 3 every time. So let's look at this one. We're going to put 1 in for n. So let's put n right there. Put our 1 in. 2 times 1 is 2, plus 3 more is 5. Now let's put 2 in. 2 times 2 is 4, plus 3 more is 7. Put 3 in. 2 times 3 is 6, plus 3 more is 9. And put 4 in there. 2 times 4 is 8, plus 3 more is 11. And again, you could have seen the pattern from each one of these anyway. It's going 5, 6, 7, so that's up to 7, 8, 9. That's up to again, and up to again. So it's going up to every single time in your output. So basically all you do is take your number that you're putting in for, n, in this case it's 1, and you plug it into this and work it out and see what you get in your output. So what if we don't know what the relation is? So here's what we're given, and we need to try to figure out what the output must have been, what the relation is. So let's do it like we did before. Let's just kind of see what the pattern is right here from this one to this one, because it should be the same from that one to that one. So let's figure out this one. 5, 6, 7. So we're going to go up 2. So to write our relation, it's going to be 2 times a number. Now, let's plug in 1 and see what we get. 2 times 1 is 2. So I'm going to need 3 more to get 5. So let's try number 2 and see if that works. So if we put 2, so if we put 2 in for n, it's going to be 2 times 2, which is 4, plus 3 more is 7. And sure enough, that will be our output. So now we can take this guy right here, and we can shrink him down and put him right up here for our output. So there's our output right there. 2n plus 3. Here's another example. We're going from 3 to 5. So you're going to add 2 on each time. So it's going to be 2n. Now plug one of the numbers in. 2 times 1 is still only 2. We need 1 more to get to it. Now, we take that one there and plug in another one. So let's plug in 2. So we got 2 times 2 is 4, plus 1 more will give you 5. So we know our answer is right. In words, you can say that the term is going up by 2 each time, or we could put it in complete words and say that the term is 1 more than twice the term number. And there would be our answer for that one, because the term is 1 more then twice the term number.